Hello students, welcome back to the second class on probability. I am Movia ma'am and in today's session we will learn to solve probability problems with help of a new technique which is termed as tree diagram. But the numeric values of the probability of an event will be calculated herewith with the same formula that I have discussed in my previous video. Let's begin our today's session. So, what comes in our mind when we listen to the term tree diagram? Obviously a tree. Look here. Here is a tree. You can see a tree from a trunk. Branches emerge. From one branch, other branches emerge. And that's how a tree grows. We use this same concept of developing further branches from the main branch in solving probability problems. I will show you how in the later part of the video. Keep watching. So, the tree diagram represents a probability problem like a branch of a tree. A probability tree diagram shows all the possible events. The first event is represented by a dot. From the dot, branches are drawn to represent all possible outcomes of that particular event. The probability of each outcome is written on each branch. Let's construct a tree diagram based on tossing of a coin twice. When we toss a coin, what happens? We either get a head or a tail. So here in this image, we can see what happens after the first toss. Either a head or a tail is appearing. So here, this tiny blue dot represents the first event or the experiment, and the head and the tail are those final outcomes of after the first toss. Here, this head and tail, as I've already told you, are the outcomes. And this black line is termed as the branch. The probability value of getting a head and a tail is written on the branch of the tree diagram. We have earlier calculated the probability value of getting a head, which is 0.5. You can refer to the earlier video for this. Now we are going to the second toss. Let's see what can happen after the second toss. Take the case of a head in the first toss. If we get a head at the first toss, it doesn't matter what we will get in the second toss. In the second toss, we can still get a head or a tail. Look here, these two instances are written over here. If we get a tail in the first toss, we can either get a head in the second toss or a tail in the second toss. And if we get a tail in the first toss, we can also get a head and tail as the final outcome after the second toss. So these all probabilities are 0.5 as there are two events only, head and tail, and I have shown how to calculate this 0.5. Now I'll be showing you how we calculate the probabilities of the end result. It is very simple. Let's first explain all those outcomes. So after tossing a coin twice, these four are the possible outcomes. Two heads, head, tail, tail, head, tail in the first outcome, head in the second outcome, and tell, tell. These four combinations are the total outcomes of this particular experiment. And if we want to know the probability of getting two heads, a particular incident, then we have to move through this branch and we have to multiply along the branches. See, here I am multiplying 0.5 with 0.5 to get the probability of getting two heads, and the result is written here. Similarly, the probability of getting head in the first toss and tail of the second toss is 0.5 into 0.5. And it is written over here. Similarly, we have moved through these branches to get tail head and these branches to get tail tail. And another important thing is that, as mentioned in the earlier video, all the possible outcomes of any experiment, the probability values, if we add up, we will get number value 1. So the probability values of all possible outcomes are equal to 1 if we add them up all. Here we have done this addition and the value is coming to 1. Now we will be solving some problems with help of this tree diagram. Let's have a look on problem number 1. Let's say we have 11 marbles in a bag, 4 green and 7 blue. We need to calculate the probability of picking 2 green marbles. First, then picking a green marble in second draw, and third question is picking at least 1 blue marble. So the steps of solving this type of problems are, first we have to draw the tree diagram, then we have to calculate the probabilities of the branches, and then we will be getting those final probability values. So let's start constructing the tree diagram after the first draw of a first marble from the bag. After the first draw, two things may happen. Let's start from the beginning. The point on the far left, this black point, represents the bag with 11 marbles. Branches represent possible outcomes. In this case, for the first draw, we will have two possibilities. We picked up 1 green marble or we picked up a blue marble. Possibility of picking up a green marble is 4 by 11, as there are 11 marbles in total and 4 green marbles are there. So the likely outcome divided by the total number of outcome gives the result of 4 by 11. And by help of the same logic, we are getting the probability values of getting a blue marble, and that is 7 by 11. Now, the second draw has happened. We have taken out another marble. After the first draw, we definitely have 10 marbles left in the bag, right? It doesn't matter what we picked in the first draw. In the second one, we can still pick a green or a blue marble. If we pick green in the first draw, in the first branch that you can see here, for the second draw, we have 3 green marbles left, as we have picked up 1 green marble in the first draw. Okay. So the probability of picking green marble is now 3 by 10. However, blue marbles were left intact. The probability of picking a blue marble is 7 by 10, as you can see. If we picked blue marble in the first draw, blue marble in the first draw. For the second draw, we have 6 blue marbles. The probability of picking blue marble is now 6 by 10. However, green marbles were left intact. The probability of picking a green marble is 4 by 10. I hope all of you have understood why I am taking 10 in the denominator. Because earlier there were 11 marbles in the back, and in the first draw we have taken 1 marble out. So there are 10 marbles remaining. So in the second draw, we are taking 10 marbles while calculating the probability. So here we will be calculating the final probability value. And here are the final outcomes. 4 possible outcomes are here. 2 green, 1 green, 1 blue, 1 blue, 1 green, and 2 blue marbles. To calculate the probability of each outcome, we multiply the probabilities along the branches. The probability of picking green marble in the first and in the second draw is equal to this value multiplied with this value. 4 by 11 into 3 by 10, that results in 6 by 55. The probability of picking green first and then blue is green first and then blue, this instant. So we have to move through these 2 branches. 7 by 10 into 4 by 11, which results in 14 by 55. And the last question, likewise the 2 remaining probabilities are 14 by 55 and 21 by 55, which you can calculate over here. For getting blue and green, we can simply multiply these 2 values, and to get blue and blue, we have to multiply these 2 values. Okay? So here we are writing all possible outcomes and their probability values in one tree diagram. And this is looking like we have calculated all the probability values that of those outcomes, and I have shown you how I have calculated. Now we are answering our question. Probability of picking 2 green marbles. We can see from here, it is 6 by 55. Second question. Probability of picking a green marble in our second draw. A green marble. So 2 pieces are there in the second draw. First green, second green, first blue, second green. Then we are adding these 2 values up and resulting 4 by 11, as you can see. Probability of picking at least 1 blue marble. Here comes another rule of probability. I have already explained this rule in our previous video. So how can we get the probability of picking at least 1 blue marble? This means there could be 3 instances. At least 1 blue marble here, here, and here also. 2 blue marbles. We are thinking of getting at least 1 blue. So these 3 instances. So what we can do here? And in this case, only in this case, there are no blue marbles. So as we all know, the probability of getting all the possible outcomes, the sum total is 1. So we are simply deducting the 2 green marbles, the probability of getting 2 green marbles from 1. That rule is the probability of not getting anything, not getting an event, say A equal to 1 minus probability of getting that event. Remember, I have explained it in the first video. So I'm applying here the same logic and we are getting this value 49 by 55. 1 minus P probability of green. 49 by 55. Now we will be solving problem number 2. Here, a bag A contains 10 balls, of which 2 are red and 8 are black. Bag B, another bag, contains 12 balls, of which 4 are red and 8 are black. A ball is drawn at random from each bag. One ball is drawn from bag A and then one ball is drawn from bag B. 2 bags are here. Draw a probability tree diagram to show all the outcomes of the experiment. The next question is, find the probability that both are red, both are black, one black and one red, at least one red. Let's construct the tree diagram. So after the first draw from bag A, what we can get? Either a red ball or a black ball. And the probability, there were 10 balls, right? And we have calculated the probabilities as we have calculated. So in bag A, the probability of getting A is 1 by 5 and 4 by 5. You have to calculate this probability at your home in your own copy. And after the second draw from bag B, what happens? Either a red or a black. These two balls can appear and the probabilities values are 1 by 3 and 2 by 3. You also have to calculate these probability values at your home. It is your homework after seeing the video. So then moving forward, tree diagram with all events and their probabilities will look like this. I'm sure by now you can understand how I'm calculating the probability value of getting 2 red balls, right? I'm moving to this branch and this branch, and red and black, this branch and this branch. We are multiplying these two values and getting 2 by 15, right? And similarly, I have calculated the values of getting a black and red here and black here. So our tree diagram is complete here with those experiments, their outcomes, and those probability values. You can also add all these probabilities values and have to see what comes in the result. So I'll be solving this question now. Probability of picking 2 red balls. Here in this instance, probability is simply 1 by 15. We will put that. Probability of picking 2 black balls. Here we are getting that 2 black balls. We are directly putting 8 by 15. Now probability of picking 1 black, 1 red. 2 instances are here. First draw red, second draw black, and first draw black, second draw red. Both of these cases are resulting in 1 black and 1 red ball. So here we have to add these two probabilities, 2 by 15 plus 4 by 15, which results in 2 by 5. Now our last question. Probability of picking at least 1 red ball. This same logic is applying here also, the rule of probability. Probability of not happening an event is 1 minus probability of happening that event. And here at least 1 red ball. 3 instances are there where we are getting at least 1 red ball. Red, 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 black, black, red. So we are simply deducting the probability of getting 2 black balls from 1. And here is the result, 7 by 50. Thank you all for watching this video. I'll be back soon with another video where we will walk through the field of probability to explore the different events. Till then, solve the questionnaires and feel free to comment if you have any doubts regarding the tree diagram. Bye-bye. Take care.